Okay, we're starting off Goal 2.1 by giving you all of the rules of solving. Okay, so this is for everything for the whole chapter, the whole Goal 2. We're not going to be hitting all of this today. We're not going to hit any fractions today, but that's going to be step number 1. We are going to hit some that have grouping symbols. So if they're grouping symbols, we need to get rid of them. Step 3 is probably the one that most people don't do that make it more difficult. I won't really know if you're doing this until I see your assessment, so I may have to come and check your OTLs a little more carefully to see if you're not doing this. Because if you're not doing number 3, you're going to make it harder. Okay? Number 4, the first goal that we're going to do are only going to have x's on one side, so we don't have to worry about moving x's. Goal 2, though, we will be moving x's. To move x's, you're always going to use addition or subtraction to do that. It's never multiplication or division. Constants to the other side, again, addition or subtraction, only not multiplication or division. And then lastly, getting x alone is usually always a division, if you have to even do it at all. Okay? I tend to like my x's on the left side, but you'll see that when we get to Goal 2.2. Okay? When you have an equation, which means that you have something with an equal sign between two expressions, it's important to understand what an equation really means. The left and the right side of the equals look different, but they are the same. Kind of like having a quarter in one hand and 2 dimes and a nickel in the other hand. They look different, but they're equal. So if you want to keep them equal, you got to do the same thing to both sides. So where I have this 2 quarters, or 1 quarter in one hand, 2 dimes and a nickel in the other hand, and I'm going to add $1 to both sides. I can add 100 pennies. I can add 10 dimes. They're the same, but they look different. Stays equal. So what you do to one side of equals, you have to do to the other side of equals. When you first learn to solve an equation, your teacher may have taught you to draw a line down where the equal sign is. So what you do to one side of the line, you got to do to the other side of the line. Okay? I don't typically do that, but if you are someone who does and that's helpful, I want you to do it. If you came to me and were having trouble and you kind of were struggling with solving, I would make you do this. I would draw this in every time. Okay? I'm not going to do it, but I would do that for you. Okay? To move stuff from left to right, that's always addition and subtraction, the opposite of what you see. So, start off very simple. X minus 4 equals 22. I want to get my x by itself, so that means I'm going to plus 4 to both sides. What I do to the left of the equals, I have to do to the right of equals. Then my x comes down. Positive and negative 4 cancel. Equals comes down. 22 plus 4 is 26. Whatever's written there is exactly how you would punch it into a calculator. Okay? Again, we're starting off pretty simple. Example 2, I'm going to get x alone. So I'm going to get rid of plus 5 by minusing 5 on both sides of equal. Negative x comes down. 5 and negative 5 cancel. 11 minus 5 equals 6. Never leave your answer negative x. If you have negative x, you've got to get rid of the negative. You're going to do that by dividing by a negative understood 1. Divide by negative 1. So negative x over negative 1 gives me positive x. And 6 over negative 1, negative 6. The next 2 examples have x on the right side. I'm going to leave it there. I'm not going to move it. There's only x on the one side. I'm going to leave it there. X will end up on the right. So on this first one on the left side here, 26 equals 37 minus x. 37 is what I'm moving. The sign of the 37 is a positive sign. So we're going to subtract it. So again, if addition and subtraction is not your thing, use your calculator. And when you punch it in, you're going to punch in exactly like this looks. 26 minus 37. So negative 11 equals 37's cancel, negative x. Never leave x negative, so divide that by negative 1. Negative 11 divided by negative 1 is a positive 11 equals x. 76 equals x plus a negative 18. So sometimes it's written a little weird like this. That means I'm going to get rid of minus 18. So to get rid of it, I'm going to add it to both sides of equals. 76 plus 18 is 94 equals x. 18's cancel. So x is 94. All right, before I go on, I want to talk about checking your work. I'm not going to make you or force you to check your work, but if you had time allowed after you finished an assessment and they weren't ready to be turned in yet, I would take some time, especially ones that maybe you struggled a little bit with. So to check this on your calculator, you're simply going to put the value you got where x is. So I would punch into my calculator 26 minus 4, enter. Here I would put in negative 6 plus 5, enter. 37 minus 11, enter. 94 plus negative 18, enter. Am I getting the number that the problem has in it? If you don't, you know your answer is wrong. Okay? And that becomes more apparent like when you get to these bigger questions. Plug it in, see if you're getting the right answer. All right, so this next two are multiplication. When the variable and the coefficient are next to each other, that indicates multiplication. So to undo it, I'm going to divide. So I'm going to divide by 5 on both sides of equals. 5 over 5 gives me 1x. That's why we do it. Gives me 1. Negative 45 over positive 5 gives me negative 9. Negative 17x equals 0. So that's a negative 17 times x. So to get rid of negative 17, I'm going to divide by negative 17. And I have x equals 0 divided by negative 17 is 0. 0 can be an answer. Okay, some multi-step questions here. Here I have an x term with a constant equal to 71. So first job is to get the x term alone. That means move the constant term, the number without the x. So to get rid of minus 9, I'm going to add 9. So 5x, 9's cancel, equals 71 plus 9 equals 80. Divide by 5. X equals 80 divided by 5 is 16. So again, if I wanted to check this, I would go to my calculator and punch in 5 times 16 minus 9, enter. Do I get 71? If I do, I'm right. If I don't, I'm wrong. Here's where that rule number, I think it was 3, can't remember what order it is. Yep, collect like terms. If there are like terms to combine on either side of equals, do that first. Like this one. On the right side, I have 2x terms. So I'm going to combine them. I'm not moving them. I don't do any sign changes. Just combine them. Negative 7, positive 4 is a negative 3x. Minus 9. Now I want to get my x term alone. I want to get minus 3x by itself, so I got to move minus 9. So I'm going to plus 9 to both sides. 12 plus 9, 21, equals negative 3x. 9's cancel. And then last step, division. Divide by negative 3. And x is equal to negative 7. The next question is very similar to that one. x term alone first. So I'm going to add 4 to both sides. So I have 11x, positive and negative 4 cancel, equals 29 plus 4 is 33. Divide by 11. So I get 1x, or x, equals positive 3. Do not be afraid to use your calculator. Sorry, let's see what I have. So on this one here, I'm going to minus 9 first. So 0.6x equals 14.4 minus 9. That is not right. And I get 5.4 divided by 0.6. And I get x is equal to 9. Okay, parentheses. This is the first one that had parentheses in it. So first I'm going to distribute. Get rid of parentheses. Never move anything before you get rid of parentheses. 5 times x, 5x. 5 times 2, positive 10, equals 25. And then it works like the last 2 examples. Get rid of plus 10 by minusing 10. So 5x equals 15. And then divide by 5. And x equals 3. Your calculator has parentheses, so if you were going to check this, 5 parentheses, 3 plus 2, close parentheses, enter. Your calculator parentheses are above your 8 and 9. So they have parentheses if you want to use that when you check. Okay, and my last one for goal 2-1. Do not take negative 8 plus 2. Common mistake. Distribution comes before addition. Get rid of the parentheses first. So 12 equals negative 8. Now distribute. 2 times x, positive 2x. 2 times the negative 3, negative 6. Collect any like terms, which I do have on the right side. I can combine my negative 8 and my negative 6 to give me negative 14. So I can write that as either negative 14 plus 2x as I did, or I can write it as 2x minus 14. Get x alone, add the 14. So 26 equals, 14's cancel, 2x. Divide by 2. And x equals 13. Go to my calculator, negative 8 plus 2 parentheses, 13 minus 3 close parentheses, enter, and I should get my 12. So definitely, if you have some time, especially on ones that maybe are a little bit bigger like that, use that time and check your work.